I'm going to chapter 2 now. Kinematics in one dimension. We'll be defining displacement, speed, velocity, acceleration. All these are important to be used in problem solving, and we should know that. The first one is displacement. Displacement is a vector point from initial position to another initial position. Okay, again, displacement is a vector, mind you that, and the unit is in meters. See figure 2.1 page 26, where you have x0 vector plus delta x equals x vector, or delta x vector equals x vector take away x0 vector. Now we're going to go and define average speed. Mind you, average speed is not a vector, it is scalar quantity, because the speed doesn't say which direction the object is moving. So that's why we'll define now distance over elapsed time, how much distance the object moved over a period of time, and the unit is meters per second. That's speed. Now comes average velocity, and velocity is a vector because it has a direction, is going north, east, west, south, wherever it is going, has to be defined. The same speed, let's say 2 miles per hour north, that is not the speed, it is the velocity. But if it just says 2 miles per hour, it is the speed. But 2 miles per hour north, east, or west defines the direction, it is velocity. So average velocity is displacement over time, elapsed time. So V is x vector take away x0 divided by t minus t0, delta x of delta t. Here x is your point where the object reaches after some time, which is t, but it starts from x0, reaches x, t0 time-wise, reaches t. So difference of delta x, which is displacement over time change or elapsed time, will give you meters per second. That's your average speed. And also remember, velocity is a vector. Now comes instantaneous velocity. Instantaneous velocity is the same thing as we defined delta x over delta t, where delta t limits to 0. It's a very close gap. Let's say you have one interval is 1 second, the second interval should be very close to 1 second. That's how we define delta t, and that's why I have in the factor where you have delta t equals or tending to 0. Next definition comes is the average acceleration. Acceleration is change in velocity with elapsed time. So you have final velocity take away initial velocity divided by time take away initial time. This is acceleration. All these are vectors because velocity is a vector. So finally we can define acceleration equals delta v over delta t. V is the final velocity, v0 initial velocity, delta t is the time interval, and the SI unit for acceleration is meters per second square, or meters per second per second. Then we have another definition here. instantaneous acceleration. Okay. Same thing, we defined already the instantaneous velocity where the time interval is close to 0 or tending to 0. So you have delta V over delta t close to 0. So please go over example 3 and 4 on page 30 and 31. Then we'll have in page 33 the equations of kinematics for constant acceleration. The acceleration remains constant. The other variables we can put in together to figure out equation to solve problems. You have 5 variables as you see here, and we will be relating all these 5 variables in the form of an equation, so you can use it in solving problems. Look at here. We have 2.4, 2.7 and 2.8, and you have the last one defining the distance. All the variables are listed on this side. Velocity, acceleration, time, distance, all that. You have 5 different variables. You have 5 equations, so you can have only 4. From there you can derive another one, becomes 5 depending on what problem you are solving. This is a very important page, and this is an important table, which is table 1. You should know the equations and should practice more on solving problems, and you have to go over the worked out examples as I mentioned to you guys. Okay, the first one you should go over is example 5 on page 34. Then we have a topic of freely falling bodies on page 40, and we'll be going over 2.13 and 14. Please note that you can also use these equations as you see in table 2.1 to solve problems on freely falling bodies. The acceleration of an freely falling body is called the acceleration due to gravity, which is g. It is showing you here the problem solving insight or strategy. This is a nice example. You can look at the picture, it's nothing much to explain. Here the coin goes up and coin moves initially with some speed, which is actually velocity going in a direction, and slowly the velocity decreases and finally becomes 0, then comes back to the position where it was thrown up. So you have acceleration due to gravity. Going up is positive, coming down is negative, as you saw in the mark. And this is a very nice example and explanation. For an ideal motion, as you look into figure 212 on page 40. In vacuum, if you allow two objects to move and they will fall at the same time, maybe you're throwing a small stone and a paper, so they will drop at the same time. This is a free falling example. The air resistance is neglected and the acceleration is constant, as you see in this figure there, and that defined to be free fall. Now acceleration due to gravity is g. G is constant, is 9.80 meters per second square, or could be in feet, like g equals 32.2 feet per second square. This almost ends chapter 2. What I am planning to do is I'll post some problems beside the problems you have to do for your homework, and also the problems I believe you are going over the examples worked out in your book. So homework problems worked out in your textbook, and some of the problems I'm going to show you how to do it sometime this week or beginning next week before the exam starts. So you will have exam for chapter 1, 2, 3, and the next chapter will be chapter 3, where we will be using the velocity vector being resolved into two different components, one in the direction of y, other in the direction of x. You do not have to worry for that right now. Just make sure that you understand the vector and how the vector diagram is drawn and how the components is found out, and simple definitions of displacement, speed, velocity, and acceleration, and those four equations. Okay, those four equations in different way will split into components and use that also in chapter 3. That will be for the next week, or for the time being. I hope all of you will make sure that you understand vectors and chapter 2 definition and how to solve problems using those equations. Okay, thank you. Have a nice day. I'll talk to you in a couple of days, or I'll post you some problems. As I said, you can go yourself. Bye now.